Hi, my name is Nick Skoretz, and I want to walk you through a suite of tools that I made that came about as a collaboration between two classes here, LING 3020 Linguistics and Technology and CIS 4010 Cloud Computing. What I developed was a pipeline of tools to help researchers collect source code files into corpora. Corpora are a collection of usually text files compiled for a purpose, and usually they have layers of annotations on them, such as linguistic information or speech information. Usually these corpora are focused on natural languages, such as English, but my pipeline focuses more on collecting source code files into a corpus. Now, why am I looking at source code? Well, there are some arguments that programming uses languages. While it's not as free flowing as English, it's not as natural, perhaps it can still be analyzed with corpus linguistics methods. And that's why I'm trying to compile it into a corpus for research. The main place to find source code files online is GitHub. GitHub is a massive website with tons of repositories of people's code, open source, free for use. I'm focusing here on the C programming language, so we can browse the C topic in GitHub. These projects contain many other files, not just C source code files. They are themselves pretty much a folder online for all types of different things. So how can we automatically extract just the files that we need to be further processed? That's where the pipeline comes in. Now, the pipeline was designed using tools in the cloud, specifically Amazon Web Services. It was designed this way and in a sort of microservice architecture way so that each individual part can scale to any theoretical amount of traffic that is hitting it. So to give a demonstration of the pipeline, we can take these two first projects that show up and we copy their names into a manifest file that is going to look like this. Here you can see NeoVim project and the SCR CPY project. We then send it off to the entry point of the pipeline and we get a response. What this is doing is it's going to these locations, downloading the files, filtering out only the files that we're interested in, which are C programming files, and then putting them in one location, kind of like an online folder, for easy collection and access. We can take a look here. Our folder has been created and files are starting to filter in. Right now 11 files, now 14, now 15. This cloud project is defined using Terraform. This is an infrastructure as code tool that allows developers to declare their infrastructure in a programmatic way so that it can be put up, destroyed, and copied to other people's clouds easily and isn't just ethereal. If we take a look at the design of the pipeline, we can see 4 steps that are currently implemented. The first step is an API gateway that catches the request that we sent. The second step parses that request. The third step uses a queue to distribute those requests to different worker nodes, and these nodes download the files into that one location that we saw. Further improvements that we could do to this project would be to include a website front end so that it would just be a website with a form that would start the pipeline. And on the other side of the pipeline, we could add more, such as to tokenize and tag the files as they're coming in, and then perhaps returning the whole collection of files as a zip to the user so it can be downloaded and analyzed in your program of choice. That's a quick walkthrough of the linguistic C code pipeline that I developed using cloud technology that I learned in the cloud computing class, and the whole purpose which came from the Linguistics 3020 Linguistics and Technology class.